Hello, grade 12. Welcome to our continuation of the topic pattern, sequence, and series. But in this particular case, we're going to be focusing mainly on geometric sequence. This is a new one, and it's a new word for you, but geometric. In this particular case, we're just going to browse through the basics on how to get around questions. Then on other videos, we're going to be tackling on how to answer exam type questions. But in this particular case, we're given an example to say we have one here, and then we have three, and then we have nine. So whenever we're talking about a geometric sequence, we're talking about a sequence where the next term, except for the first term, where the next term is going to be determined by multiplying with a constant value. If you can check, we have one. How do we get three? We say one multiply three. Then we're going to get our three there. Then for us to get the nine, we need to multiply this three with that three. So if you can check the three there, it is what? It is constant, or rather it is common. That's why we're going to call it a common ratio, to say for us to be able to get the other terms, we have to use a common ratio by multiplying with it. So this one is different from the arithmetic and the quadratic sequence. Why? Because we know that in this case, we're going to be multiplying and not adding, or rather, we're going to be dividing and not minusing, as we had used subtraction to find what the difference. So how do we find the difference in this case? But firstly, let's check. Our equation, or rather our nth term, is given to us by a multiplied r to the power n minus 1. This is the equation that will determine your geometric sequence. In this case, a, as we always know, it is the first term. Then now we move on to the new one, which is r. Our r here, it is what we call our common ratio, or some prefer to say constant ratio. It is still the same. Then we know that our n is just the position of the term. So how do we get about this one? R, if you can remember with your common difference, with the linear or arithmetic one, it was term 2 minus term 1. Then in this particular case, it's going to be term 2 divided by term 1. How do you prove that it is a geometric? You're going to have to say that term 3 over term 2 must be equal to term 2 over term 1. So you're going to see that once we start exploring the questions in the given example on the left. So let's get into it. Remember, what you need to keep in mind, it is the equation to say Tn is equals to AR n minus 1. What is important? We already have the A value, so we can say that Tn is equals to R n minus 1. Remember, once you multiply with 1, you can either indicate it or not show that you're multiplying with 1 there. So what is important for us to find now, it is the R value. So how do we do that? Remember I said term 3 over term 2, then you're going to have term 2 over term 1. So let's do that. In the space of term 3, we have 9 divided by 3 equal to, then we're going to have 3 divided by 1, which both of them are going to give you the value of what? Of 3. Hence, I showed in the beginning to say, how do you get the next term? You just multiply with the constant ratio that is going to be there. Check. 1 multiply 3, you get 3. 3 multiply 3, you get 9. So now if they say write down the next two terms, we know that we're going to take 9 and multiply it by 2, which is going to be 27. Then the next time, we're going to take 27 and multiply it by what? By 3 again, which is going to give us 81. Now we know how to get the next ones, but what happens if you now have to get the 50th term? Because in this case, we go into the large values. So you're not going to be counting, or rather doing it manually. You're going to be using this particular equation in such a sense that Tn now, it is going to be, it is very advisable that you put your R always in bracket form so that you cannot confuse it with this one, because if R has an exponent or an unknown exponent and A is a value, you cannot multiply them because one is a coefficient and the other one is a base. So in this particular case, we have 3 and then n minus 1, meaning that our equation, which is going to be 3 to the power of n minus 1. So this is our equation here. Then we move on to these second questions to say, is the sequence a quadratic or a geometric sequence? So in this case, we show that it is a what? It is a geometric, even though we already knew that we're dealing with only a geometric. But how do you prove it? It is because the constant ratio, it is what? It is constant there. Or rather, it's the same. It is a constant ratio. So now, write down the general term. We've already done that. Then they say find the 10th term. Finding the 10th term, it's going to be T10, which is going to be equals to, remember, it is 3n minus 1. Then in this case, 10th position, it is going to be 19,683. So in this case, Tn is equals to 3 to the power n minus 1. Then this one is geometric. Then we have 27 and 81. Then in this case, it is going to be 19,683. Then now they ask you which term is equal to 531,441. So in this particular case, what you must always know that whenever you're calculating the term, you must always know how to use your exponents. Because as you can see, the nth term here, it is in exponential form. So that's one other thing that you must know to say this one grows a bit quicker than the quadratic and the linear because it grows exponentially. That we're going to find out now to say which term it is actually equals to 531,441. Then in this case, we know that substitution, it is going to be 531,441 equals 2. Then on the other side, we're going to have 3n minus 1 because it is equal to that. No need for you to divide with the coefficient because the coefficient is just 1. So what you do in this case, you can use your laws of exponents to reduce this one. For you to reduce this one, you just press on your calculator this value and then you say equal to. Then you're going to have to say shift. Then it's going to be fact, meaning that you're going to be factorizing it. In this case, it gives you 3 to the power of 12 and then you have 3 to the power of n minus 1. It's not always going to be this easy, especially whenever you have a coefficient this side. So in this particular case, we know that if you share the same basis, if the values on the right and the left, they share the same basis, you know that you're going to drop the basis and then you equate the exponent. So in this case, n will be equals to 12. Taking the one to that side, you get plus 1, meaning that n is equals to 13. So term 13 is going to be equals to 531,441. That will be the answer to that. So that was it about the geometric sequence. So on the next one, we're going to be focusing on the sigma notation and the arithmetic and geometric series.